All right. Hello, everyone. Thanks a lot for coming and welcome to Vigo. I hope that your flight was quick and easy. Mine was a bit long, but hopefully I'm here. So I'm Antonis. I work for a company called Platform.sh, where we create a platform as a service. We're an infrastructure provider. We have also a booth. So if you want to hear more about what we do and what is Upsun and how you can have an easier life deploying your applications and especially Django applications, feel free to reach out, although we'll see a few things in the workshop. Personally, I'm a Django developer. I've been coding Django since 2012, 2013, something like that. I remember I have a t-shirt that says now migrating. It was, I think, Django 1.6. Before that, we were depending on other tools for migrations, and now we have a better life with Django migrations embedded. So let's hope that we can make our lives a bit easier and see how we can do this with when we have rolling updates, when we have more interesting deployment setups. So let's get it started. By the way, if somebody can see the stream and they have any issues, let me know. Otherwise, we will continue because we're also streaming some people the workshop. So what are we going to talk about today? So we're going to get ready. This is what we do right now. We're going to talk about Django deployments. I'm sure that most of us in here have deployed at least once our application, but we're going to go back to the basics. We're going to talk about, what are the building blocks, how we do this, and all those things. And then, we will take a bit of our happiness, and we are going to talk about static asset management, which is great, but, it has a lot of work sometimes, and maybe we can do this easier. We are going to talk about schema migrations, which is amazing, as we talked about, because, everything from our models goes directly to our database, but what happens during deployment, and even worse, what happens if we need to roll back, or if we need to run the application in multiple versions at the same time. And we're going to talk about the challenges, and then at the end, we're going to see a few examples and potentially solutions, and we're going to have a discussion. So let's get started. And I think understanding the Django deployments and the building blocks is maybe the most important thing. Usually, our setup, it can be what we do locally. It can be something that we have set up on our own server, or it might be something more interesting that we have set up in a cloud or through a provider like Upsun. Is comprised from those things. On top, we have a proxy. It can be your favorite server like Nginx or your Caddy server or whatever. Then we have our app servers. We have a CAS, hopefully, or usually, and a database. That's like the minimal thing that you need to run a Django application. Of course, we can have things like a cellular worker or other interesting stuff alongside that. But this is like the minimum viable product, the MVP of a Django application. So for the proxy, are you using something different? I think that most people will start from those things. So if you have not heard of those before, that's fine. Nginx is my personal favorite, but again, that's up to your taste. Caddy has been very common lately in traffic. If you're more into the containers ecosystem, maybe you've seen traffic a bit more. So the idea of the proxy server is that's going to handle things like your TLS. So you have an HTTPS connection coming. You need to stop the TLS there, negotiate it with the browser or the application that's talking to you. And then from that proxy, you're going to continue to your application. You're going to do things like the domain name. So depending on if you're pointing the www dot whatever your server is or other things, you're going to do redirects from non-www to www or the reverse and all those things. For the application server, we're going to, that used to be the case. It's not the case anymore, but those were the the most common servers. Who's here is deploying using Unicorn, for example? Okay, I see like maybe 50%, I would say. Anybody deploying with the Uvicorn? A few hands, nice. So you have your async code in there with sync to async and reverse. You're very, very brave for doing that. Any other servers? Is anybody here deploying with a different server on those? No. So okay, I got quite a good of the idea here. So The application server is the server that's actually running your Python application. So when the request comes in, if the request needs to be served by an API code, or if you in Django, it's going to be served by one of those two servers. And those two servers have a few good things and bad things. Everybody complains that Python is slow. Python has the global interpreter lock and all those things. We know that we love Python, so let's see how we're going to do this a bit better. So usually those servers are going to serve one request at a time. And the way that we're going to scale those servers is by having multiple processes running one next to the other. This is not necessarily true for the ASCII interface, which is the asynchronous interface of Python, because finally we can have the cool things of event loops and the other things that other ecosystems had in the past. But the idea is that we have process-based management of those servers. For the class, just the examples, nothing serious here. I mean, it depends on what you prefer doing. But Redis and Memcached used to be one of the favorites. My personal one is Redis. Usually you will see my favorite thing or tool on the top. And Memcached has been around for a while. I personally prefer Redis because when it comes to Redis, you can do other things as well. So Redis is not only for forecasting, it supports streams, it supports queues, supports other things. So sometimes you want to reuse the same tool for multiple purposes within your application. And then for database, Postgres and MySQL, like the most common ones. I've started with MySQL. I've been continuing with Postgres, and of course you can have things like MongoDB or other things, although these are not directly supported in Django. Also, another thing that many people use lately is SQLite. You might use this for your local deployments, or you might use SQLite for not local deployments, local development, and you might use SQLite as well for production environments. We've seen many people doing that lately. It has a good thing that it's very fast, very easy to deploy, to manage, to back up and everything. But on the other hand, if you have multiple servers and applications, it's not as easy. So now that we have the basics, let's start talking about a few of the things that you are going to stumble upon when you deploy your first application. So let's say that you develop your application locally, you do manage by one server, everything runs perfectly, you have your static assets and all those things. But now you deploy. The first time that you're going to deploy your application using the Unicorn or a similar server, you're going to see a very nice broken screen. So you say, okay, what's happening here? The thing is that Django is doing a lot of nice things when you develop locally, like serving your static assets, but when you go to production, you're not going to waste those application server resources to serve static assets. As we talked about, Python application servers can serve one request at a time, in quotes, because that's not necessarily true with the ASCII interface, but still, this is very resource intensive. And that's very good when you serve Python code, because when you serve Python code, you want to make sure that you get away with GIL and all those things. But when it comes to a simple CSS or JavaScript file, that's not really the case, because let's say that I load a Python application that has 20 different static assets, like 5 images, 2 JavaScript files, CSS files, all those things. I don't want to waste all my application server resources just to serve those static assets. So by default, Django is not going to serve those static assets for you, and you have to find an alternative way. Like any suggestions for tooling around this? No? Nobody? What are you using? You're not serving static assets in production?
Nginx.
Nginx. So here comes, the proxy. You remember in the beginning we talked about the proxy in front of your application. So you can configure your application so that static assets like routes like /static, which is the most common one, are going to be served by your proxy or whatever you have in there. And then the rest of the Python code is going to be served by your server. But then you have to make sure that your proxy has all the static files. So what are you doing there? Maybe replicating the static assets to all servers, or building collecting static, to all servers. Maybe that's a solution. Another common solution is to use something like white noise. Anybody has used white noise in the past? Oh, a few hands, nice. So white noise is a library in Python that's going to serve your static assets, and it's going to make sure that your static assets are very well cast and everything. That's very good, but still, your static assets are going to be served now by your Python application. So in order to get past that, you need to put your proxy again in front of you, and that proxy is going to cast the static assets in the edge. Or maybe you have a CDN, and then the CDN is going to cast those static assets. And the third solution would be to use something like an external CDN. So you have somewhere external outside of your application where you push your static assets, and then you serve them from there. So for example, you can have things like an S3 bucket or those things where your static assets are going to be served by there, and then your application is going to continue being served by your Python code. So how are we going to mix all those things now that we talk about, in general, into more specific things in Django? So first of all, the static assets can support multiple storages and multiple finders. So that's two very nice tools that we can use to better handle our application. So first of all, storages. Storages are the way of Django of storing those static assets after it has post-processed them. So Django is using, actually I should have put those in reverse. So first we have the finders, which are the modules, let's say, that find the static assets inside the application. The default way of doing that is going through its Django application. So let's say that I have 3 Django applications, my users application and my sidings, as we will see in the hands-on example later on. And then so Django is going to go to those applications, go to the static directory. So that's the predefined one. And in there, it's going to find all the JavaScript images, CSS files, and so on and so forth. After finding those, it's going to use one of the storages in order to store somewhere those files so that we can serve them later on. So in the case of the Nginx server that we talked about in the beginning, we are going to store those static assets in a directory that's going to be available by the Nginx or whatever proxy we have in front. That's very easy and very straightforward. But what happens if we have multiple servers? Then maybe we are going to do this on every server. That's one solution. Or the second solution is to use a storage that's external to the application. So we're going to push the static assets outside. The other solution is to use white noise, or maybe there are other packages that I'm not aware of that do the same thing, which is serve the static assets, hash them. So there's a special storage called the hashed static file storage or something like that. Oops. That's going to, let's say that you have a file called main.js. It's going to hash it and rename it to main.hash.js. And that hash is going to be saved in a JSON file that's going to do all the mapping, and then be able to share those files with permanent cache, like cache it until the end of Python 3. Let's hope that's not going to be very close to us. That's the static file storage. So the default one is just copying files from your applications to a directory or an external directory that you want. And the manifest static file storage is going to hash them and store them. As we said, the manifest static file storage is the one that is going to allow us to cache those files indefinitely. Because otherwise, let's say that I'm seeing the application now. I have a CSS file saying that I want everything to be black and white because that's my current theme. I get a request from design. I want to make sure that I include this nice yellow color that is now introduced in our brand. I'm updating the file. It's being collected. It's being served. But maybe some clients have cached locally the old file. So until this actually propagates to all the customers and all users, I'm going to be yelled at by marketing or by design. And of course, we do not want to be yelled at. So having a manifest static file storage is another nice thing that we put here, but it presents us an issue when it comes to deploying applications in production and having multiple instances of the application running. We're going to see those in a bit. Wrapping up, I want to make sure that we have all the initial bits and pieces in place so we can get our hands dirty, we have schema migrations. So schema migrations are what? Are files that describe a change in state. So let's say that I have a database with a table that has 3 fields. I go to my model, I add a new field, and that field goes and creates a new schema migration. So that as soon as I apply the schema migration, my database state will go from the previous schema to the new schema. That's it. It's very simple. Also, it supports rolling back. So it supports the reverse operation of going back to having 4 fields, back to having 3 fields. That's a very good thing because when it comes to Django, at least personally, I have forgot how to make sure that my database has, all the schema that it needs to have. Because for all those years, I've been, just writing models, writing migrations, and everything happens automatically. The bad thing is that I have forgotten how to write SQL. Sorry about that. I Google a lot, and thankfully we have things like Copilot, OpenAI, and other AI tools that write very good SQL code. Those migrations also have orders, dependencies, so it's really, really easy and really handy to do them because I can make sure that they're applied in the correct order. Django keeps track of what has been applied, what hasn't been applied, and all those things. So in general, they are great. But what happens as I deploy the application and maybe multiple versions of the application start running at the same time? Then I need to plan for that, and this is the second thing that we're going to talk about today. Now, going back to the basics, we talked about 2 very important things and 2 very nice things that Django presents to us, which is schema migrations and static file storage. But we said that maybe we have challenges when horizontally scaling those applications. Why this is a challenge? This is a challenge because there might be more than one version of the application running at any given point in time. This sounds very easy and very simple, but it's a very, very big trap that we might fall in. The reason for that is that applications have become more flexible. We would not have like a single server that we deploy the application and then we do manual deployments, but we have multiple servers. Maybe we do what we call rolling updates, where we deploy the application to a new server and then slowly and gradually decommission the old one, and so on and so forth. So this presents challenges. So for static assets, we talked about how to serve static assets without depleting app server workers. But it's not as easy because we talked about a single Nginx server in front. It's not easy if you have multiple servers or if we do this rolling update. How do we serve the correct cache? Or how do we serve, let's say that we have a web page, and the web page is going to do 5 requests. And just for this example, let's imagine that we do not have HTTP2 that makes sure that we have a single connection for everything and all those things. And let's say that for some strange reason, some static assets are going to be shared by application A, and some static assets are going to be shared by application B. Sorry, by server A and server B. In that case, if server A and server B are in the same version, that's good. No problem here. But what happens if, for some strange reason, because of a proxy failure or whatever, the request ends up in a wrong server? In that case, let's say that we have a new static asset with a new hash, and we try to request it from an old server. We're going to get back a 404 and a broken page. And same happens with the reverse. So managing all those application versions has introduced a new problem. So we solved a lot of problems like zero time deployments and all those things. But we have thankfully introduced a new one. So as developers, we are lucky because we have a new problem to solve. So this is what we're going to try to solve today. The second one that we're going to solve today is how to apply schema migrations. At which point in time do you apply the schema migrations? Do you apply them before deploying, after deploying, between deployments, if it's like a rolling one? This is another big question, because if you add or remove fields, if you change like the default value, I suppose that you can live with that because it's a default value. Potentially, you already have code that can handle this change. But what happens in additions, deletions, or changes in the way that, for example, we have uniqueness in the application? For all those things, we need to make sure that we, first of all, plan for that. So our code is not as easy. We have to make sure that those migrations happen in a specific order, and maybe through multiple deployments. That might be another strategy. And the other thing is what happens with rollback. So let's say that we have a deployment. it failed, or maybe we have a bug that we did not intend to, and we want to go back to the previous version. With the application, that's very easy. Just go back to the previous version. Most of the systems that we use at work have this ability, and potentially we have already baked this ability inside our system, or maybe we have, like a commit that's a revert commit that's going to be deployed and then have the old version of the code. But if this code included migrations, then things start to be a bit more interesting. Because running back, okay, it's very easy. It's as a command, migrate application name to the previous version. That's how Django does it. But is it as easy? Personally, in my production experience, I've seen many times where I was very, 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 very confident about being able to go back to the previous version. And you can guess what happened next. It wasn't as easy. So if you want to follow along, this is a repository. It's under my GitHub account, so github.com/akalipetis/Bigfoot. This is the application that we're going to use. And also potentially we're going to install the Apsan platform CLI. I'm going to deploy to Apsan as well for the sake of the demo, but this is something that you can do either later on if you want to, or on your own time. It's not necessary for now. So let's see how we can plan for those things and see how we can make things better. So back in here, let's see. Okay. All right. So let's start with the application, which is a very simple one. Actually, what I have done here, is the size okay for you at the back, or should I make it a bit more big? Okay, cool. So I have a very simple application which has one Django application inside it, applications and applications, which has a model file with a few models. So nothing very serious here. Users, sightings. So the application, just for context, is an application that people can report sightings of Bigfoot. I've seen it. It's somewhere out there, so we're going to find together. And then we're going to add comments to those, and a simple application using Django. This application is completely identical with the old one. The reason that I have two applications here is that it's not as easy to showcase problems that will happen, when we change versions. So instead of trying to be fast enough to cast these through deployments, I'm going to deploy two applications, like the old one and the new one, at all times, so we can see all those problems in real time. So the old one is going to be the one that we are going to start working on, and then the new one is going to be the one that we're going to start adding features into it. So let's see what I have here. Let's make sure I have cleaned up everything. Nothing fancy here. I'm just using Docker locally to start those two applications, and this means that I have so nothing fancy here. I have one application on the left, which is, I think, the old one, and one application on the right, which is the new one. I have opened the two ports. And as we talk about Bigfoot. If I go to admin, provided I remember what user I have created, I should be able to add new sightings. So I'm going to create a new super user. I'm going to go to sightings and add a new one, demo. By the way, I love how Django is providing the admin. That's one of my, when I talk with friends, it's my go-to thing. try Django. It has admin out of the box. You don't have to care about this thing, and your customers or your users will be happy about it. So that's the thing. I saw it too. That's the comment. Of course, I'm not putting the correct data in here, but the idea is that we can have it like this. So as you see, we have a site in here, and we have a site in here. So both applications have the same data. They look into the same database because that's what we're going to see here, and everything is fine. So now I need to start changing things into the new application so that we can start seeing all those problems and how they arise. So let's leave the user as is. We don't really care about the user, but the citing. Okay, we have a title, description, owner, etc. Let's start with a simple change. So in here, I would like to make sure that the title is unique, for example, because we want to make sure that sightings are not duplicated or would not have spam from users trying to input the same thing. So what I'm going to do here is update the model in here, and then go to new, and then do something like make migrations. So make migration is going to create a new migration, as we talked about, which is going to have this change, which is very interesting. This is how Django adds these operations. It says that this is an alter field operation. So we are changing a field in the database, and the new field, the new data for the field is this. So very simple. Now we are in the case where we have the new application. It's not deployed yet, and we have the old application which is running. And actually, let me verify which is the old one. So the old one is import 8000. So here is the old application. It's running. Nothing happened here. Nothing changed in the database. I can still go and add new things. And of course, I'm not going to add a new duplicate citing because that means that this will fail afterwards. So this is the beginning of the application, the beginning of the deployment. I can go here and start the deployment. The deployment process typically would be that I deploy a new version of the application, and before requests start coming into the new version of the application, I'm going to run my migrations because I want, as soon as the application is up and running, all the database schema to be ready for me to start accepting requests, because maybe my code depends on those requests. So I'm going to do migrate, and now we're going to application, old version of the application running and the new version of the application running at the same time. Nothing fancy here. So my migration was applied to the database, but the old version of the application can still work. Why? Because what I changed was not a very big schema update. It was not something that I need to plan for. That's very easy and handy, so I can be happy about it. Let's see that I continue updating my application. Now, a new request comes in from legal and compliance and says, we need to get GDPR approval of the people adding new sightings. Of course, we're in Europe, we love it, but sometimes we have to click a lot of checkboxes before we can use applications. So we go here, we do something like GDPR, GDPR OK, and then I'm going to use a Boolean field, which by default should be false because I have not taken any acceptance from existing sightings. And let's leave it like this. So what will happen here is that the new version of the application will go to add a new field to the database. It's going to have a new default value. And probably this is not a big issue for me because the old version of the application does not know about this field. So maybe I will be fine. So let's continue doing that. Let's see the migration as well. Where is the migration? GDPR, here it is. So nothing fancy here. Another Django operation, which is called add field. So I'm adding a new field to the database, and I'm using this model, this field, and this is the actual field that's going to be populated in the database. Perfect. I'm also migrating because let's say we start deployment, and okay, everything is okay. Now, a friend of mine comes in and says, I saw Bigfoot yesterday, so I have to go to the admin. Okay, that's fine. Let's go and add a new sighting. They tell me that, okay, I sighting in Vigo. This option to add the GDPR compliance because I'm still on the old version of the application. I will not add any comments for now. I'm just going to add this to the database, and here the problem starts happening. So what happened here is that I have a field in the database that says it cannot be null. And the old version of the application tried to save a new row in the database without adding this field with an explicit value. So why did that happen? Because Django, when it has defaults, it can have like a Python function and other things, so the default cannot be in the database with an asterisk. We are going to talk about it in a bit. But by default, it cannot add things in the database as defaults, and this means that the default value actually happens when the model is going to be saved in the database. So because the old version of the application does not have this new field, everybody trying to save a new sighting during a deployment that lands to the old version of the application is going to get a 500. And 500 errors are not something that we want to have in the application. So let's go back and see how we can potentially solve this. Any clues or any ideas on how we're going to do this? No? Maybe we can leave 500, maybe it's for a minute or two, it's fine. But apart from that, let's say that it's not something that we can accept. So from the error methods, I'm getting that we cannot have null values in that column. So what I'm going to do here is going to make sure that this can be null. If I remember correctly, I think that's the field in the database. So what I'm saying here, so instead of doing the migration like I did before, just with the default value, I'm going to allow null values so that I do not get this crash. So I'm going to make migrations again, migrate again. So new version of the application is coming out. And let's see if we can make this work. So it did work, and we're great. Or are we? If we go back to the database now, and let me check what's the best, what I can do is the Django cell. I'm going to do from Bigfoot models import, oops, sighting. Let me remember the private key. So this is the sighting that we just entered in the database. And if I go to the GDPR, okay, I don't get back any value because this value is actually none. So what happens here is in the database, I might have a few sightings with false, which are the old ones, a few sightings with null, which are the ones that created after the deployment, but before the old container was decommissioned, and the correct ones that happened afterwards. So I have 3 values in the database instead of 1. So maybe I solved my problem for now, but I still have invalid data in my database. This might be okay, so we can make sure that our new version code handles this correctly and handles null in the same way that it handles false. But this is a very specific case, and maybe we have a field with more interesting data in it. So I don't think that this solution is the best one. What we would do in this case would be to go and update, do something like sighting objects update with GDPR. Okay, we are actually going to filter with GDPR. Okay, equals none, and update everything with GDPR okay equals false. So we're going to deploy a new version with a new migration, which is going to be a code migration that's going to run this command. So after 2 deployments, I'm going to have the correct state in a database, and maybe in between, my new version code is going to handle correctly null and false values alike. So now if I do the same thing, I get false because that was a null value and now it's a false value. So, okay, we solved the problem, but maybe the solution is not great. One of the things that have been finally introduced, and I'm very happy about this in Django 5, is that now you can have DB defaults. So instead of doing that, let's go back to the initial case. So for that, I'm going to roll back the database migrations to the first stage, which was this one, and I'm going to migrate Bigfoot to here. So what happens now is that my code is now back to the old version of the application. Sorry, my code, my database, so that I can still do changes. So what I'm going to do here is going to add DB default. DB default means that the default value is not going to be assigned by the Python code, but it's going to be assigned by the database itself. So it's like a hook that happens there. And in that case, I'm going to also delete the migrations because I don't need them anymore. I don't need this. I don't need this. And I'm going to make migrations again. So now, in theory, nothing changed. I can still go here and add a new siding. Let's try and do this again. So a new siding. I'm very clever with descriptions. This is a title. I think that AI would be better than me in deciding those values. Let's go, let's go, let's go. I will assign a better score to this one for no particular reason. And now this was saved to the database without any issues. But again, we need to go back and see if actually this was what we wanted to do. So again, we saved something from the old version. The old version has nothing to do with GDPR. So let's see what happens in the database in here. Now I'm going to get the one with primary key equals 4. And GDPR, okay, it's going to be false. So now we actually managed to do what we want in the database. We've been going back and forth a lot with migrations and all those things, but what I wanted to keep up from this is that even though we have migrations, even though our migrations are great, we need to make sure that our migrations are forwards and backwards compatible. So we want to make sure that we do not create migrations that actually break the code that's going to come into the future, or migrations that are going to break the code that existed in the past. So we need to be very thoughtful of those, and especially, when it comes to user-facing code. Of course, there are other tactics that we can follow. For example, we can add everything in the database, but then expose the APIs. So we do this again in 2 steps. One step is doing the migrations, putting the code, putting the models, putting everything, and then exposing those APIs or those views to the user. So in that case, we do not mess with those models, but it's not always possible. We can have models like this one that existed before, and then we just want to append another new field into there. The second thing is about static assets. So now for static assets, we are going to see a few things, and we are going to do them together. But unfortunately, I could not think of a good way of serving requests between those 2 applications from the same domain. So for a few of those things, you are going to take my word for it that things work this way. So for that, we're going to go here and do collect static. So let's do compose run, exec. Alt, it doesn't really matter. I'm going to do collect static, and let's add more verbosity so that we can do this. So what happened here is that Django went to all our applications, found all our static assets, and then created this app static directory. And actually, we can go and see this. So we went to the old one, which is here. We went to static, And then you see here that we collected all the static assets from within the application. So now we're using the default static assets collector, so that's good. Which means that we don't have any extra files, we don't have any special cases, but the problem is that if I, for example, go and change, not this, let's go to the CSS. Let's go to the background color. I want to change the background color to, I don't know, RGB. Let's hope that Copilot will help me here. Come on. Oh, it has a color picker. Okay, I didn't know that. Let's use this color. Okay, so I'm changing the background color into the old application. Of course, it's not working because I'm taking out the wrong file. No. Okay, now it's working. So I actually stumbled upon the same problem that I was going to talk to you about, which was that I had cast the old CSS file. My browser said, okay, this is the same file. Maybe I will not care about it. I will not try to contact it. Also, maybe it used a header that checked against the size of the file, but the size did not change because the characters were exactly the same. I just changed the color, so the characters were the same. And it was not going to pull the file from the server. So the problem here is that the old application and the new application might have differences, but those differences might take some time, and that time is not dependent on us because the browser might have its own policy. It might follow cache headers, might not follow cache headers, and there are many systems in between your server and your application, and maybe your users will continue seeing the dark version of this instead of the new orange version of this. So the first solution for this is go and change the static storage to the hashed storage because actually I need to let's see. I need to change the hashed storage so that we can see what happens because here, as you can see, all the CSS files, for example, the app CSS, always has the same name. Not in here, of course. In the static directory that has collected this. As you see, it's still called app.css. So now I'm going to go to the settings file and find static storage. Django host. Let's copy and paste because that's what we're good at. Do you remember the static file storage? Okay. Always have a backup branch if you do not remember everything by heart. Here we go. So what I'm going to do here is collect static again. With the correct value. With fixing this, I love CSS. Let's remove source maps. One moment and we will be ready to go. because Django is trying to find those as well. So what happens here is that in the root directory, in the build file, you see now that I have those app.has.css. So finally now I'm lucky enough, and if I change something, the browser will remember the file name. So if the file changes, the file name will change, so the application will always load the correct file. And how does Django solve this? Let's see if we can. Okay, we were lucky. So Django is creating this file which says that this file, which I found through static file storage, is renamed using this has at the end. So Django is using this file so that it can do this mapping, and whenever you load an application, you have app.css in your templates, but Django is going to replace this with the file that it finds in here. Everything is great in here and amazing. But now let's say that I go to the new app CSS. This is it. And now the background color, instead of orange, I'm going to, how did I make the color picture open? Okay, let's do something lazy. So in the new application, I do not like orange, so I change things to red. So I'm going to do collect static, but now I'm going to run collect static on the new application to see the differences. So I do that, which is great. And if we go here and we go to the static application and then we go to app.css, we see that we have this here for the old one, app CSS on the new one. We have to use the static file storage on the new application. It's very hard if you have two applications with the same code and remembering that you have to do this all the time. So let's run static assets collection again. Perfect, it worked this time. So if I go to the new application, into the static directory, come on dear, here it is. I see that I have a new app.css. The problem is that, the problem and the solution at the same time is that the old one and the new one have a different has. That's great because that's what we wanted in the first place. If the app CSS changes, we want to change the file name so that it's not cast and so on and so forth. But what happens now if I try to load the new CSS file from the old server? The old server will not have this CSS file, and this will break my application again because this file is going to be a 404. And in order to test that, we're going to go to app.css in HTML files. So I'm going to base HTML in the old app. And I'm going to cheat a bit, okay? Just let me do this. What I'm going to do here is does not exist.css. I do not remember the has, but it doesn't really matter. What I'm going to see here is that whenever I'm going to load the old application, the users are going to see something that's broken. So what we need here is a solution that's going to work across applications. And at least to my knowledge, the only solution to do that is to host the files externally. So one solution would be the S3, okay, store them somewhere in the bucket elsewhere. The other solution would be to somehow store those applications and set them by a proxy. The good thing about proxies is not only that they can, do all those management and store and set files for us, but they also have their own cache. And for example, in the Absent case, and now I'm going to switch to here, we have this nice bracket in here. So here we say to the Absent proxy, I want you to serve files. Okay, that's fine. I want you to serve them from the static directory. That's fine as well. So I don't have to push files to an external location so that they are served. But we also say that, by default, I want to keep those files for 1 hour. What does that mean? That, when we have this rolling update, hopefully our application is, visited often enough that the old version of the old CSS file will be already loaded and cast into the proxy. So the next time that's going to be requested is going to be requested by the correct application. The other thing is that this static directory can be a mount, so we can have search storage between old and new versions of the application, and we can make sure that both old and new are served from the same directory and are always available there. So that's one of the solutions. Another solution would be to use the white noise middleware so that we can serve files directly from the Python application, but then cast them. That's very handy if the proxy and the application server are in different machines. That's also another setup that we see often enough. In our case, that's not necessary because the proxy and the application server have access to the same local directory for serving the static assets. And what else do I want you to say here? And of course, we still have one very specific issue. And this issue is for new servers trying to serve, old servers trying to serve the new CSS files before the new CSS files were served. So of course, that's a very specific case, but we still have, a small percentage of cases where we cannot serve this nicely. And potentially this can be only solved in the proxy level. So in the proxy level, we should say that, every new connection goes to the new server because new is always better. We know that. And in that case, we can make sure that we will never get in a case where we're going to try to load the file, which is not hosted in there. From what I see, we're almost at time, so I'm going to go back to the slideshow and potentially get a few questions if you have any questions, comments or whatever else you need. And yeah, thanks a lot for staying until here. But the bottom line is we love Django. Django is amazing. I'm with you on that. We have very nice tooling in Django, but when our application starts to grow, we have to make sure that we do all those things, carefully, and we make sure that there are no users that are going to have crashes just because we were lazy or did not want to plan in advance when we add migrations or other stuff. So this is it. Any questions? No questions? Cool. So thank you very much. Enjoy the conference. If you want to learn more about Appsun and how you can deploy your applications and focus only on the code, we are outside. And also, if you want to have these nice bracelets, pass by our booth, and on Friday we have an after party on the rooftop. So it's going to be amazing. Just pass by and we'll be happy to have drinks and chat about Django. Enjoy.